You're standing at the edge of a massive gorge. The wind whips across your face. Your eyes strain to see the bottom of the canyon below, but it disappears into mist and shadows. A single step forward would mean certain death. Then you look up and see it. A ribbon of concrete and steel suspended in the sky. The Huajiang Canyon Bridge. Let's put this bridge's height into perspective. At 2,051 feet above the canyon floor, the Huajiang Bridge stands taller than 3 Washington monuments stacked on top of each other. If you dropped a bowling ball from the deck, it would take nearly 11 seconds to hit the ground. That's enough time to read this entire sentence twice. But this comparison only scratches the surface of what makes this bridge a true engineering wonder. The bridge's location itself tells a fascinating story. Situated in China's Guizhou province, it spans one of the deepest canyons in Asia. The region's terrain is so challenging that for centuries, entire communities remained isolated from each other, separated by these natural barriers. Local legends tell of villages that could see each other across the canyon, but required a full day's journey to actually meet. The project began in 2013, with many experts claiming it couldn't be done. The first challenge was simply surveying the site. Teams had to rappel down the canyon walls to take measurements and soil samples. Several geologists refused the job, calling the cliff faces too unstable. But a determined team pushed forward, spending 3 months mapping every inch of the canyon. But height isn't the only thing that makes this bridge extraordinary. The construction story behind it reads like an engineering thriller. The team faced 3 major challenges that nearly made this project impossible. First, the wind. At this height, gusts can reach speeds of over 100 miles per hour. Engineers had to design a deck that could handle these forces while staying stable enough for vehicles to cross. They developed a ground-breaking aerodynamic design that lets the wind pass through special vents, reducing pressure by 40% compared to traditional bridge designs. The testing phase alone took 6 months, with engineers using advanced wind tunnels to simulate every possible weather scenario. In one dramatic test, a scale model was subjected to hurricane-force winds for 72 continuous hours. Previous designs failed within the first day, with miniature sections buckling or twisting. The final design stood firm, swaying less than half an inch at the center span, a movement practically imperceptible to drivers crossing the actual bridge. The second challenge? The canyon itself. The steep walls made traditional construction methods useless. Workers couldn't simply build scaffolding from the ground up. The canyon was too deep and unstable. Instead, they had to construct the bridge from both sides simultaneously, using a method called cable-stayed cantilever construction. Think of it like building a massive diving board from both cliffs at once, hoping they'll meet perfectly in the middle. This construction method required unprecedented precision. Each section had to be perfectly balanced as it extended out over the void. Special GPS systems were installed to track movement down to the millimeter. The slightest miscalculation could send thousands of tons of steel and concrete plummeting into the canyon below. On the day the 2 sides were scheduled to meet, engineers held their breath. The gap between the sections had to be within 3 centimeters to make the connection. Temperature changes overnight could expand or contract the steel, throwing off calculations. The team chose to make the final connection at dawn, when temperatures were most stable. When the sections aligned with only 2.2 centimeters difference, the construction crew erupted in celebration. But the most daunting challenge came from an unexpected source: temperature. The extreme height difference between the canyon floor and the bridge deck creates temperature variations of up to 30 degrees Celsius. This means different parts of the bridge expand and contract at different rates. The solution? A revolutionary expansion joint system that can move up to 2 meters in any direction, acting like a giant accordion to keep the bridge stable. These joints represent a breakthrough in bridge engineering. They contain special sensors that continuously monitor temperature, pressure, and movement. The data is fed into a central computer system that predicts when and how the bridge needs to adjust. It's like giving the bridge its own nervous system. The construction process pushed human ingenuity to its limits. Workers had to operate cranes at heights where oxygen levels are noticeably lower. Every steel cable and concrete pour had to be precisely calculated. A mistake of even a few millimeters could spell disaster when building at this scale. The construction team even developed new safety protocols that are now being adopted as standard practice for high-altitude construction worldwide. The human stories behind this bridge are just as impressive as the engineering. Over 400 workers lived in temporary housing on the canyon rim for 3 years. Many were local villagers who had never worked on construction projects before. They received specialized training and now form an elite workforce deployed on other megaprojects across China. One worker, Li Wei, started as a basic laborer and is now a sought-after specialist in high-altitude cable installation. The numbers behind this project are staggering. The main span stretches 1,140 feet across the canyon. The bridge deck contains enough steel to build 3 Eiffel Towers. The foundation pillars go so deep into the canyon walls that they could support a structure twice as heavy. Each main cable can withstand the weight of 360 fully loaded trucks. The concrete used isn't ordinary either. Engineers developed a special high-strength mixture that can withstand extreme temperature changes and resist cracking under enormous pressure. This new formula is now being studied by construction companies around the world for use in other megaprojects. To test the durability of this concrete, researchers subjected sample blocks to pressures equivalent to being at the bottom of the ocean, then rapidly heated them to temperatures found in a blast furnace. Standard concrete would shatter under such conditions. The Huajiang mixture showed only microscopic stress fractures. But here's what makes this bridge truly revolutionary. It's not just about crossing a canyon. The Huajiang Bridge is part of a larger network that's transforming China's rural regions. Before this bridge, the journey around the canyon took over 4 hours. Now, just 7 minutes. Think about that change. A farmer can now reach markets in a fraction of the time. Students can access better schools. Emergency services can reach remote villages that were once almost inaccessible. This isn't just a bridge. It's a lifeline that's reshaping an entire region. The economic impact has been immediate and dramatic. Villages that were once considered too remote for tourism are now popular destinations. Local businesses report revenue increases of over 200% since the bridge opened. Property values in the surrounding areas have tripled. The bridge has literally put this region on the map. One local entrepreneur, Ms. Zhang, converted her family home into a guest house. Before the bridge, she might see 2 or 3 visitors a month. Now she hosts over 100 guests weekly, many international tourists, coming specifically to see the bridge. Her story has been repeated across dozens of villages in the region. The technology developed for this project is already influencing bridge design worldwide. Engineers from over 30 countries have visited the site to study its innovations. The special wind-resistant deck design is being adapted for bridges in other high-wind regions. The temperature compensation system is becoming a new standard for extreme environment construction. But perhaps the most fascinating aspect is what this bridge represents for the future of engineering. We're entering an era where the impossible is becoming possible. The solutions developed for the Huajiang Bridge are paving the way for even more ambitious projects. Engineers are already talking about bridges that could span even greater heights and distances. The success of this project has opened up new possibilities. If we can build a bridge this high, what other engineering challenges can we overcome? Could we build bridges across ocean trenches? Span entire mountain ranges? The Huajiang Bridge isn't just a record holder, it's a preview of what's coming next in the world of megastructures. Right now, somewhere in the world, engineers are looking at the Huajiang Bridge's success and asking themselves, what if we went even higher? Plans are already being drawn up for a bridge that could shatter this record. But the location and design of this potential new champion are being kept strictly under wraps. The only question is, how much higher can we go? Let us know what you think in the comments section. If you enjoyed this video, make sure to subscribe and watch our next one shown on screen. Thank you for watching.